Welcome, ladies and gents, and welcome to your first week of Essential Maths, learning this from home. It's going to be exciting and fun and a little bit different from what we're used to. So here we go. So this week we are learning about the Cartesian plane, generating tables of linear functions, and how to graph linear functions. So you've got a few tasks to do at home. Make sure you're still filling out your books. The OneNote has all the information as well as my versions of the Cornell notes. So I've been going through filling in my new Cornell notes. So I've got all my stuff there, and the scans of my notes are all, as I said, in the OneNote, and I'll show you that in a minute. So our first lesson, we want to learn about the Cartesian plane. How do we identify coordinates on the Cartesian plane? How do we plot them on as well? I know I'm talking fast, but you can rewind and replay and stuff as we go. So what you need to be able to do is you need to be able to plot a coordinate on the Cartesian plane, and you need to be able to state the coordinates of a point on a graph. So having a look at the Cartesian plane, what we have is we have essentially two number lines. We have a horizontal one, which we call our x-axis, and we have a vertical one that we call our y-axis. We then use numbering for each point along our two number lines that are crossed. Going towards the right is positive, and going towards the left is negative. Going up, once again, in the y-axis is positive, and going down is negative. So in terms of if we wanted to identify a point, so if I have this point, for example, on my Cartesian plane, what I would do is I would follow it down to my x, and that gives me a value of 2. And the way that we actually express points on a Cartesian plane is using brackets, and then we use the x coordinate first and the y coordinate second. So we use our x and our y. So as I said, our x value was 2, so we're going to put the 2 first. Then we need to determine what is our y value. So we're going to look across, and that's coordinating with our 4. So our coordinates are 2, 4. The second part of our Cartesian plane is we do have this thing called quadrants. And what we say is the top right is our first quadrant. This is our second quadrant, our third quadrant, and fourth quadrant. So we would say the point 2, 4 is in the first quadrant. So what if I wanted to plot the point, say, -2, 6? Remember, my x comes first. I'm going to use a different colour to plot this out. If it comes through, x, y. Our first coordinate is -2. So in our x, we're going to go to -2, and we need to go up to 6. Draw my dot. Once again, whenever we are plotting a point, we need to make sure we put the coordinates in. So we have our bracket, and it says -2, 6. And that is in the second quadrant, top left. Let's identify another one. Let's go down. Let's do this one here. So first, remember, x-axis first. So going along our x-axis, we're at -8. Then our y-axis, we're at -1. This is in our third quadrant. And finally, we're going to plot let's go with 6, -5. So going on our x-axis, we're going to go across to 6, and we're going to go down to -5. And this one is in our fourth quadrant. So essentially, this is how we go through plot a point on a Cartesian plane, how we read off. So remember, quadrants start top left, first, second, third, fourth. We describe points as x, y, and our x's are positive to the right, negative to the left, and our y's are positive up, negative down. Our next topic is around the about substituting values. So we're going to look at how do we substitute numbers into a formula. We're going to look at how do we work with negative and positive numbers when we've got them in the same function that we're trying to add together. And then we're also going to look at how do we complete a table of values for an equation. So firstly, how do we multiply positive negative numbers? So 2 times 3, so we have a positive number multiplied by a positive number. So 2 lots of 3 is going to give us 6. When we multiply a negative number by a positive number, so if we have minus 2 lots of 3, we end up with a negative. So we have negative 6. Now, note I use brackets around my negative numbers, and it's certainly a good tip when you're using your calculator to actually put the brackets in when you're typing a negative number. That way, you won't accidentally say 3 minus 2 instead of 3 times minus 2. So a negative times a positive is going to give us that negative. A positive times a negative is going to then give us a negative as well. And then finally, so that's positive times negative. If we have a negative times a negative, that makes a positive. And probably my bad way of remembering this is I go, 2 wrongs make a right. Our next topic, or next part of this, is actually trying to create a table of values for a function. So if we have the function y equals 2x minus 3, so that means 2 times x minus 3. What we do is we create a table of values. Now the values will depend on the graph that you're trying to fill out. So I've decided to go from -2 through to 2. So what we do is we substitute each of our x values in. So I'm going to say, well, at x equals -2, y equals 2 times -2 minus 3. So we need to follow our Bondasel order of operations. So brackets first, really the brackets are just holding together -2, so that stays together. Next, orders, so squares, we don't have any here. Division and multiplication, so multiplication's next. So y equals 2 times -2, which is -4 minus 3. So -4 minus 3 takes us further in the negative direction, so -7. So we end up with an x value of -2, a y value of -7. And we work through our next one at, so at symbol is at x equals -1, y equals 2 times -1 minus 3. So 2 times -1 is -2 minus 3, -5. So I'm going to end up with an x value of -1 with a corresponding y value of -5. At 0, so at x equals 0, y equals 2 times 0 minus 3. So 2 lots of 0 is 0 minus 3. So we end up with 0 minus 3. And then what we do is we continue this process until we've completed our table of values, which I have done. Our next step, or our next lesson in our sequence, is creating a graph based on a linear function by hand. So we want to be able to create, and we also want to create using technology. I'm going to use a program called Desmos, and I'll come on to that in a minute. So we want to make sure that you can create a graph by hand and you can create them by using technology. So using our table of values, we can plot a linear function. So what we do is that we've got an x value of -2, a y value of -7. So x value of -2, a y value of -7. So remember, whenever we plot, we've got to put the values in, so it's -2, -7. We've got -1, -5. We've got 0, 3, so x first, 0, -3, 1, -1, and 2, 1. So once we've got these points in, we can then draw a line to connect our points. And then we can extrapolate or interpolate. So extrapolate is going out further, interpolate is going in between what our graph would be or what our values would be. So from that line, it actually is passing through every single point as we go along. So in reality, to draw this line, I only needed 2 points that I could connect up. So preferably points that were further away from each other would give you a bit more accuracy with that line. But I would always recommend that you use 3 points, and that's a check mechanism to make sure that you are actually doing your sums right. So in terms of graphing this out, because the graph extends out, I put arrows at the end and I need to label it. So y equals 2x minus 3. So from my line, I can then, from my graphical line, I can determine different points. So if I wanted to know, well, what is x equals 5, what does y equal? I can go to my x is 5, trace up, and so y equals 7. So essentially we just walk along our line, find our values. In terms of to really identify them correctly, we need to make sure we're using an exact crossover on our graph. So using technology, we're going to use the program Desmos. So with Desmos, all you need to do is go to the website, www.desmos.com. There is a link in the OneNote. I'm going to give you a look at that now. So to go into, we're going to jump into desmos.com. So once you go to Desmos, you get a base page like this, which says, which has the start graphing in the center. So we click start graphing, and from here we can just type in any function we want. So y equals, we'll check our one before, so it was 2x minus 3, and that's our graph, and we can check. We can drag along checking any points. So for your task today, you do need to send me 3 graphs that you produce in Desmos. So from here, you can use the snipping tool to get them out. You can export them to file, so your export image, and then download the PNG, or you can even just right click and go save image. So that's Desmos. You can put multiple graphs on the same function. So y equals minus 3x plus 7. If you're having trouble with typing directly in, you can click on the little keyboard and it'll show you the keyboard so that you can type in whatever function you want. The last thing I do want to go through today is having a look at your OneNote. So with your OneNote, I can grab OneNote up. So we're in the Unit 4 tab now. We've started Unit 4. And then what we need to do is you've got your unit plan and you've got each lesson for this week, including any of your homework and exercises that you need to do in the OneNote. There's also some additional information down the bottom. Your textbook chapters are there. And as you can see, the Cornell Notes examples that I've been doing are within the OneNote as well. So we have our Zoom session as well this week. That Zoom session I have scheduled for our normal lesson time on Wednesday. So that will be at, I'll just check, at 11 a.m. on Wednesday. So looking forward to seeing you there. Your tasks, so you have exercise 8A, exercise 8B, exercise 8C to work through and sending me through those 3 solutions. If you're having any problems or issues, shoot me an email or I'll talk to you in the Zoom. Happy mathing.